All right, guys, so we're going to talk today about multiplying polynomials, okay? And as you can see in these first three problems, we're multiplying one binomial, right? If you remember, that's a polynomial with two terms by another binomial. So we got a binomial times another binomial in all three of these problems. Now, the reason that I have three mapped out is there's really three different ways of thinking about these problems, and I want to give you all the options you can. So you basically pick the best one that you think fits, what you like to do. Okay, so starting at number one, okay, I got 8a plus 7 times 3a plus 2. Anytime you see parentheses, guys, your thought should be, especially with multiplying, your thought should be to distribute. So that's how I'm going to attack number one. In number one, we're going to distribute 8a to 3a and then 8a to 2. So we have 8a times 3a, which would be 24a squared. Just be careful because a lot of people make the mistake of saying that's just 24a. Remember that a times a is going to be a squared. And then we have 8a times 2, which is positive 16a. Okay, and then I go back to the first binomial and I do the exact same thing with the 7. So I distribute the 7 to the 3a and the 7 to the 2. So I got 7 times 3a and 7 times 2. So 7 times 3a will be positive 21a. And then at the end, 7 times 2 will be 14. We're not quite done yet. Most of the time, I don't want to say all the time, but most of the time, when you're multiplying two binomials, there's going to be like terms in the middle, okay, which is exactly what we have here. So my final answer here is 24a squared plus 16a, 21a. That makes 37a plus 14 at the end, okay? Your answer here is going to end up being in descending order. Just to double check, make sure that it is in descending order. Remember, descending order is the biggest exponent to the smallest exponent. So we're good to go in number one. Number two, okay, this is a second way of thinking about this. All right, this is going to be called the box method. Some people prefer to look at this and do these in what I call the box method. So you're going to have a box, okay, and you're going to put that box into four pieces. Now, doesn't really matter where you go, but if you want to go on the top with the first binomial, you'd have a k and a minus 2. And then on the side, you're going to go with your second binomial, which is 3k and negative 7. And then basically you match them with what matches up with each box. Okay, so in this box, you would have 3k times k, which is 3k squared. In this box, you'd have the 3k and the negative 2. 3k times negative 2, which is negative 6k. In this box, you'd have negative 7 and k. Negative 7 times k, which is negative 7k. And then in this box, you have the negative 7 with the negative 2. Negative 7 times negative 2 is positive 14. Okay. And then when you go to write your final answer with the box method, your like terms are going to end up being in what I call the diagonal. So here are your like terms. So your final answer for number two is going to be 3k squared. The like terms in the diagonal, I got a negative 7k and a negative 6k. That's going to be negative 13k. And then my plus 14 at the end. So there's your answer to number two using the box method. Okay, if I go back to number one real quick. Number one, we did distributing. Okay, we thought about that one with distributing. Okay, last but not least, number three. Okay, the way I'm going to show you how to do number three is really the same way we did number one, just with a little more structure. Okay, this is called the FOIL method. Okay, FOIL. First, outer, inner, and last. Okay, so if you look at the first letter of each, FOIL, there's your FOIL. Okay, Basically, this just gives us, like I said, a little bit of structure. So your first, okay, the F, which stands for first, is the first term in each binomial. 7n times 8n, which would be 56n squared. The outer are the outside terms. Okay, these are your outside terms, the 7n and the -6, which would be -42n. The inner are your two inside terms right here. These are your inside terms. 8 times 8n, which is positive 64, positive 64n. Pen's acting up there, guys. I'm trying to finish that 6 there. Positive 64n. And then the last are the last term in each binomial. So the last term there, and then the last term there, which would be 8 times -6, which would be -48. And then again, you would have like terms in the middle. Okay, at least most of the time that's going to happen. So I'd have 56n squared, -42 plus 64, -42 plus 64, that's positive 22n, and then -48 at the end there. So your final answer there is 56n squared plus 22n minus 48. So 3 different ways of thinking about these types of problems. Okay, you can think about it distributing. You're just make sure you're distributing twice. Okay, the middle problem there, number 2, is the box method. Okay, where you kind of match them up in boxes. That's another way to structure it. And then number 3, which is really the same thing as number 1, it just gives you an acronym to kind of help you out there. FOIL, first, outer, inner, and last. Okay, and this is for multiplying binomials. Okay, now what happens when I change it? So let's take a look at another example here. What happens when I have something like this? I have a binomial being multiplied by a trinomial. I have something with 2 terms being multiplied by something with 3 terms. FOIL, the FOIL method that we discussed in number 3 in the earlier example, is out the window. I cannot use FOIL, okay, because you're going to have first terms, right? You'll have your first and your first. You'll have your last and your last. Okay, you'll have your inners. Okay, you'll have your outers. The problem is, in all of those, you're never factoring in the -3n. So we cannot use FOIL here. But what we can do is we can distribute. It's just going to take us a little bit longer. 4n to 2n squared. 4n to -3n. 4n to 8. And then we would go back and we would do the exact same thing with the -4. -4 to 2n squared, -4 to 2n squared, -4 to -3n, and -4 to +8. So I'm distributing here. Okay, 4n times 2n squared. Be careful here. That's going to be 8n to the third power. Remember your rules for exponents. Product of powers. N times n squared is n to the third. Okay, 4n times -3n, that's -12n squared. Again, be careful there. 4n times 8, that's +32n. -4 times 2n squared, that's -8n squared. -4 times -3n, and negative times a negative is +12n. And then I got my constant at the end. -4 times 8, that's -32. And then just make sure you combine your like terms. Okay, so I got like terms there and there with the n squareds, and then I got like terms with the n's. The 8n cubed, there is no other n cubed in the problem, so that's going to start. Remember, descending order. All right, so I started off with my n to the thirds, then I'm going to go with my n to the seconds. -12n squared and -8n squared is -20n squareds. Okay, then I go with my n's. 32n and 12n makes plus +44n. And then we always finish with the constant, -32. So your final answer there, 8n cubed minus 20n squared plus 44n minus 32. Okay, so still distributing. Okay, you can still distribute. You can't use FOIL. Don't try and use FOIL. You could also use the box method for these. Okay, and I'm not going to go through the whole thing, but if we were to set up the box, now you would have to have a box where you have a 2 by 3. So it would look something like this. Okay, you would put your trinomial up top and your binomial along the bottom or along the side. Okay, and then you can match it up that way. So this would still be, and again, I'm not going to go through all the numbers, but you're going to have 8n to the third power there. You're going to have negative 12n there. You're going to have positive 32n there. Okay, this is going to be negative 8n squared. These are all the same numbers I got to the left there. This is positive 12n. Okay, and this is negative 32. And when you look for your like terms, I said earlier, they're going to be in the diagonal. It's no different here. Okay, you're still going to have like terms in the diagonal. I actually made a mistake. I got n squared in there. This should be negative 12n squared. Your like terms are still going to be in the diagonal. You got diagonal right there with like terms, and then you have a diagonal right there with like terms. Obviously, the 8n cubed and the negative 32, they don't have like terms. So you're still going to have like terms in the diagonal. It's just going to be a little bit different than we did in the earlier example. Okay, hopefully this helps you guys. Good luck.